Hello everyone, this is my second lecture on Introduction to Database Systems in the course Database Management Systems. In the first lecture, we had covered what a database is, some applications and examples of databases, the database management system and the database system and metadata. So, we will continue from here. Let us take up the drawbacks of the traditional file system, or we may say the database system versus the traditional file system. We already know what a database system is. A database system consists of the database and the DBMS, which is the collection of programs to manage the data in the database. By the traditional file system, we mean the data files that we are creating through the application programs which are written in high level languages. When we talk of the traditional file system, then we are using some programs written in high level languages to create the data files and as well as to use the data files. In that case, all the data that is created in the data files, that is dependent on the application programs that are creating those data files, which also means that in case we want to change the data file, then we may have to actually do some changes, make some changes in our program files. If we want to change the way we want to see the data, then we may have to make some changes in the program files that are using the data. Whereas, in the case of a database system, we have already seen that the database is stored as a collection of data at a single place. It is not dependent on the software that is creating that data. The software which is creating the data or the DBMS, it is entirely independent of the actual storage of the data. So, now we will see that what is the drawback of the traditional file system against the database system. First, let us take up data redundancy. Now, when we talk of the traditional file system, let us take an example that in a college system, the department of the student, the registrar office, the accounts office, they are all having data and they are storing and using the data about the students. Now, let us consider that the department needs the data roll number, name, age and the contact number of the students. The registrar office, it needs the data of the students, and the accounts office needs the data about the roll number, name, age, fee paid and the outstanding. Now, what is happening in the traditional file system is, since the department is needing data on roll number, name, age and the contact number of the student, they are writing some programs to create the data files to store this data and to use this data. Similarly, the registrar office is writing some programs to create and use the data files corresponding to the data that is required by them, and same is for the accounts. Now, we see that in all three cases, student number, name, they are common. Here the between the department and the registrar office, the contact number, they are also common. That is, within the same college or the same enterprise, we are storing the same data at different places as per the requirement of the different users. As a result, the disadvantages are that there is duplication of effort, because the same effort to store that data and is being made at different places, and there is a wastage of the storage space. Why? Because again, wherever the data is stored, storage space is being used. So, these are the disadvantages of the traditional file system as far as the redundancy of the data is concerned. Whereas, we already know that in a database system, we have a central pool of data where all the data is stored, and this data is used by all the users of the system irrespective of where they are. So, that means the same data is used by all the users, and all the users, they need not create their own data files. So, we say that the database system is able to control the redundancy by storing the same data at a single place, and all the users, they have the access to that data. So, as compared to the traditional file system, there is no duplication of effort and no storage space is wasted. Next is integrity. What do we understand by integrity? Integrity means applying the same rules to the same data. For example, here we have just seen that the department, the registrar office and the accounts, they need the student data, and all of them, they are storing the data on roll number, right. Now, it may happen that the department stores the number as a integer value, the registrar office stores it as a character value, and also the accounts office stores it as a character value. So, that means the same data in the organization is being stored at different places in different forms using different data types, or we can say different rules, they are being applied on the data. With the traditional file system, this problem of data integrity exists for the reason I have just explained, whereas again in the database system, since all the data is stored at one place, so whatever rule is applied, for example, the roll number is taken as a integer value, then that holds true to the data irrespective whoever accesses that data. Third is the problem of data inconsistency with the traditional file system. Data inconsistency refers to the fact that, let us say, there is some change in the data. Now, change in the data in the sense that a student in the college changes his contact number. The student contact number is stored in the department as well as it is stored in the registrar office using their independent file systems. The student informs his department that I have changed the contact number, and he gets his contact number updated in the departmental data file, whereas he forgets to do it with the registrar. So, what happens for the same student, the telephone number that is existing in the same organization, but at two different places is different. This is an example of data inconsistency. Let me give you another example. We said the name of the student is being stored in the department, the registrar office and in the accounts office. Now, there is a student Shiv Kumar Yadav. So, what the department does? Stores the name of Shiv Kumar Yadav as this, whereas the registrar office writes so, are they the same student? Why? Because the data, they are now written differently in the two places. Whereas, when it is a database system, then again it is a central pool of data and the name of the student will be stored as Shiv Kumar Yadav, or in this form, whichever form it is stored, it will be available to each and everyone in that very form. So, the problem of the data inconsistency that exists in the traditional file system is overcome in the database system because of the fact that in the database system all the data is stored as a central pool of data. Program data independence. We said in the beginning that in the traditional file system, the data files, they are dependent on the program that are creating the data files. So, in case there is a change to the database, we want to make a change to the database, then we have to actually change the program that has created that data file, right. Whereas, in the case of the database system, the programs for creating and managing the data, they are entirely different from the data which is stored in the database. So, what does that mean? That the data is independent of the programs that are creating the data, which is known as program data independence, and it is helpful. Why? Because to change the data in the database, we do not have to change the programs, and in case there is a change in the program, then the stored data is not affected. So, these are some of the advantages of the database system over the traditional file system. Some more characteristics of the database system are the self-describing nature of database, data abstraction, sharing of the data and multi-user transaction processing, recovery of the data, restricting the unauthorized access to the data, and providing search techniques for efficient query processing. Let us have a look at all these one by one. Self-describing nature of the data. We have already studied what metadata is. It is data about data. That means that the data about the data, what are the data types, what are the constraints, what are the access mechanisms, all these are stored in a catalog called the dictionary, called the data dictionary, in the form of metadata. So, the data itself is described in what we call as the metadata. Data abstraction actually results from program data independence. We have said that the programs and the data, they are independent of each other in the database systems. So, what happens is that the users, they can see the users, they can also see the data at different levels of abstraction as is required by them. That means, let us say I am a user of data and the data that we have stored is the roll number, the name, the age and the city of the students. Now, I as a user of this data is concerned with only the roll number and the name of the students. So, I can view or retrieve only the roll number and the name of the students, whereas some other user may be wanting the roll number, the name and the city of the students. So, that person can retrieve the data required by him, which is the roll number, the name and the city. So, the users, they can retrieve the data whichever they required, and different levels of abstraction are maintained. Another important thing over here is that the users, they are not concerned with how the data is stored in the physical storage. This data is there in the database, that is, let us say roll number 1, Amit, 23 belongs to Ghaziabad. Roll number 2, Suman, 22 age, she belongs to Delhi, and so on. The data is stored in the database. Now, the users, the end users of the data, they are not concerned with how this data is stored in the database. They are concerned with only the data that is required by them. This is called data abstraction. Sharing the data and the multi-user transaction processing. Like I had told you in the previous lecture, when we talk of the database system, then the very concept of the database system means that the central pool of data is being stored by multiple users, and the multiple users, they may access the data simultaneously at the same time. For example, if we talk of the railway reservation database, then thousands and thousands of users, they are accessing that data at the same point of time from different terminals and locations. So, the same data is being shared by a number of users at the same time through transactions, through different transactions. Same is true for a college system. There are a number of students, they may be accessing the data at the same time. At the same time, the faculty may be accessing the data, and so on. It is the concurrency control system of the database management system that ensures that the updation of the data by several users at the same time is managed in a controlled manner, so that the result of the updates is always correct, which means that when the number of users, they are accessing the data and any user is making an update to the data, then it is important that this update should be reflected everywhere and to everyone. Recovery of data means that the system, it must return back to a consistent state in the case of a hardware or a software failure. What do we understand by a consistent state? A consistent state means that a state which is a correct state. Let us take an example of a banking system where we talk of two accounts A and B. Account A has 10,000 rupees and account B also has 10,000 rupees, right. Now, we want to make a transaction such that we transfer 1,000 rupees from account A to account B. So, that means minus 1,000 over here. We have already initiated the transfer of 1,000 rupees from account A to account B, but immediately after that the system fails. So, what happens is, what is the state of the system at the time of failure? Amount in account A is 9,000 rupees, but before that amount could actually reach the account B, the failure happened. So, still here the amount is 10,000 rupees. So, total amount A plus B at the beginning of the transaction was 20,000, whereas after the system recovers or it comes back after the failure, what is it? It is 9,000 in account A, 10,000 in account B, which means the total sum over here is 19,000, which is an inconsistent state. Now, it is important for the database recovery system to ensure that when the system comes up or when the system restores, then either the system should return back to a stage that this transfer or this minus from account A is reverted and the amount in account A is 10,000. So, that A plus B is 20,000, or in case this does not happen, then it should make sure that it should make sure that 1000 rupees has been transferred to account B, so that A plus B is now 20,000. This is what is meant by data recovery, that in case of any failure, the database system should come back to a consistent state as before the failure or as expected after the failure. Characteristics of the database system we are doing. The next is restricting the unauthorized access to the database. We have already seen that multiple users, they share a large database. For this reason, it is required that all the users are not authorized to access all the information in the database, which means, like we just did an example for the department, the accounts and the registrar maintaining the data of the student. The accounts is maintaining the data regarding the fee details and the outstanding dues of the students, which may not be required by the department. So, the department will be authorized only to see the data that is required by the department. The registrar office will be authorized to see and use only the data that is required by them, and also for the same for the accounts office. Again, another example we may take up is that we have a number of users in the database system, and all the users may be given permission to perform different tasks on the database. For example, some users may be permitted to only view the database, some other users may be permitted to view as well as update the database. So, this is managed through the security and the authorization subsystem of the database management system through the account restrictions and the permissions. Efficient query processing. Whenever we are querying or accessing the data from the database, the access should be an efficient access. That means, it should take the least amount of time. Specialized data structures and search techniques are there to speed up the disk for search of the desired records, and one of the examples is the use of indexes. Next is database users. Till now we have been talking of only the end users or the people who are using the data. However, there in a large organization there are many people or individuals who are involved in the database, such as the designers of the database, people who will design the database, people who will use the database, people who will maintain the database, and people who will do the administration work on the database. This may not be required for very small databases such as a personal database. A personal database can be where I am trying to, let us say, record the phone numbers of my friends in a database. So many users may not be required, but for a large database system, we have different categories of the users, like the database administrators, the database designers, the end users, and the application programmers and software engineers. Database administrators, they are the people who manage the entire database. That means that where the database is going to be stored, who are the people who will have access to what part of the database, who will have access to what function on the database. All these permissions, they are granted by the database administrator. It is the job of the database administrator to see that the data in the database is available to all the users as and when required. The second category of the database users is the database designers. They are the people who will design the database, that is, they are the people who will decide what are the tables in my database, what are the attributes for these tables, what are the data types for the various columns in the tables, what are the constraints that are there on the columns, and what are the relationships between the various tables. All this is done by the database designers in consultation with the people who are going to use the database or the client. The end users are the users who actually use the database. For example, in a college system, we can say the students are the end users, faculty are the end users, registrar office is the end user, the management is the end user, and so on. In the banking system, we can say the bank employees are the users and the customers, they are the users. So, these are the end users who actually use the database. And the last category is that of the application programmers and the software engineers who will write the programs to manage the database, and they will also write the application program. They will also write the application programs in some high level languages, which can be used to embed the structured query language statements to use the database. These are the four categories of the database users that we generally have, and all these they are important for any database system. These are the references for the topics that we have done today, that is the fundamentals of database systems by El-Masri and Navathe, and database system concepts by Korth, Abraham, and these the second book is by McGraw-Hill and the first book it is by Pearson Education. Thank you.